Okay, now we're going to take a look at number 16, in which we have f of x is 3 to the x. So our output is 3 to the x. That's what we'll call our base function. So this one is relatively straightforward. I invite you to pause and see if you can predict a few key points for this one. And then if you're back, hopefully you have come up with a few key points. You've probably checked out what y is if x is 0. You may have checked out what y is if x is 1. So those are a couple of basic ones that we can always get pretty easily. So 3 to the 0 power is going to be 1, and 3 to the first power is going to be 3. Now, this one isn't going to be too hard to get 3 to the second power. So if x is 2, it's 3 to the second power, or 9. And it won't be too hard to get 3 to the negative first power. And the negative first power, if I raise 3 to the negative first power, that's like dividing 1 by 3. It's making 3 a divisor, so that's 1/3. Okay, and then we can do one more here. Or 3 to the negative 2 power is just going to be the reciprocal of 3 to the second power. The reciprocal is, if I flipped 9 over 1, I get 1/9. So I've got negative 2 is my x value, and then 1 over 3 squared is 1 over 9. And there we have 5 points. Okay, so this is our base function, and we can plot this base function. It's going to be right over here. If I plot some points, looks like I need to put a comma in somewhere or fix something for Desmos' sake. Probably this 1/9 is not making it happy. Still not making it happy. So maybe it's this 1/3. There, now it's happy. Okay, I'm going to move it a little bit. So there we have our base function with table of values, and then you can make your swoop that's going to be swooping up through a y-intercept that's just 1 and an x value of 1, y value of 3. Right there, it swoops up to the right. It's a growth function. And here is the function 3 to the x. And it works just nicely. Okay. And we also have this other function, which is based on it, which is g to the x plus 4. So now I'm going to make points at -1. Actually, let's check it out. So what am I going to have? So how would I make this exponent have the same effect as an exponent of 0 in this one? Because that's part of the trick. You want to look at the exponent and say, okay, how could I make this x plus 4 equal to 0? Well, the number that would make it equal to 0, I'll invite you to pause this. There's actually going to be 2 x values. So we want an x value that gives us the same y value that makes 3 to the 0. It makes 3 to the x plus 4 the same as 3 to the 0. We also want an x value that makes it 3 to the first power, which will give us a y value of 3. And then we'll also do similar things for the others. We'll see what it takes to get us a 3 to the second power. So we get a 9, and I'm just putting in the y values. Okay, so there's comma, there's comma. Okay, so there's 1/3 and 1/9. So those were the outputs we got over here for this function. Okay, these are outputs you could easily get for a base of 3. You can get 1/9 if you have -2 as an exponent, 1/3 if you have -1, 1 if you have 0, and 3 to the first is 3, and 3 to the second is 9. Okay, so what would we need to do to make x plus 4 equal to 0? Pause the video and see if you can figure that out. And when you do, plug that in here because 3 to the 0 will be 1. Okay, hopefully you've worked out that to get x plus 4 to equal 0, x has to be negative 4. So a negative 4 for x will give us the same output as this function did if x was 0. So plug in negative 4 plus 4 is 0. Okay, now let's see what it takes to make this into a 1. Well, negative 3 plus 4 would be 1. So we'll plug in a negative 3. And then negative 2 plus 4 will get us 2. So it'll get us 3 to the second power. And you can see we're just, every single one of these is 4 less than the x value over here. So 0 became negative 4, 1 became negative 3. So you can probably predict what will happen here. So go ahead and see if you can figure that out really quickly, and then come back. And if you're back from that, you hopefully figured out that negative 5 plus 4 will get us negative 1. So that'll be 3 to the negative 1, or 1/3. And negative 6 will get us an exponent of negative 2. So we'll get an output of 1/9. Okay, so let's go ahead and plot those points in Desmos. Okay, and you notice we've got corresponding points. They all rhyme with the previous function, and they're just shifted over. They're shifted 4 to the left. So that's interesting. Having an x plus 4 as the exponent shifted us horizontally 4 to the left. But having an x minus 3 shifted us horizontally 3 to the right. So if you recall from the Desmos activity I gave you, where you had your exponents being so a, b to the x minus h, well, if I wanted to shift 3 to the right, h would be 3. If I wanted to shift 3 to the left, or 4 to the left, h would be negative 4. X minus negative 4 is the same as x plus 4. So this is a tool you can use for transforming a function. If you want to shift horizontally, you add or subtract something to the x. And that'll work very nicely for a lot of manipulating of your functions. So we'll go back in here and plot, see if this is actually accurate, 3 to the x plus 4. I'll experiment a little bit with it. I made it x plus 3 plus 2 plus 1. I shift back towards my original one. Okay, and that's the same as minus. So I shift minus negative 4. So what I've done is I've shifted everything to get the same values 4 over to the left. Same y outputs 4 over to the left. And I hope that has been helpful for you. I'm going to stop this one. I'm going to go ahead and do some quick videos for the other problem.